Okay, continuing on from where we left off with our hands-on portion of our simple and series circuits, we're now going to show, how we do a parallel circuit and how that affects the devices that are on it. So what we're going to do is, you've already got a wire connected. I'll put these wires on to these alligator clips for our motor. Then I'm going to put on the wires for the lamp. And I'm going to leave the motor disconnected, but I'm going to leave the lamp attached, because that will show a fundamental part here and how parallel works. Yeah, I think you can see that. I'll start it up at 1 volt. Okay, our lamp is lit, and as you can tell, unlike the series circuit, it's back to the way it was when we started with the simple circuit with the lamp by itself. So what I'm going to do now is we're going to increase it to 3 volts. That way you can see a little better. Okay, now we're running at 3 volts and our light is nice and bright. Now we're going to take our wires here and we're going to plug in the motor. And you'll see if the light changes any. The light didn't do anything. As you can see with a parallel circuit, these devices are running independently on their own set of wires. So unlike series, each one of these has their own circuit. In series, all these would be working together through one circuit. And as you saw, when I took a wire out on the other one, everything went off. But as you see on a parallel circuit, I can take the motor off the circuit and this light will still be lit up. So I can work with the motor here and it won't do anything to it. Now you might see the light flicker a little bit, and that's normal because the motor is applying load onto the entire circuit. Now, one difference between the series and parallel circuits is the amperage of the circuit. When we were doing the series circuit earlier, we were only pulling less than 0.2 of an amp at 3 volts. We're running at 3 volts here, but we're running it on a parallel circuit setup now. And looking at the ICE's status here, we're pulling a lot more amperage than we were before. On a parallel circuit, we're now pulling 0.8 of an amp. 0.8 of an amp as opposed to less than 0.2 of an amp when it was on series. So that shows you that the amperage draw is fundamentally different between a parallel and series circuit. And like I say, I can change the voltage. And see, like I say, we're now running at 1 volt now. And our light is still bright as it was by itself. And of course our motor is turning slower now. But still, we're drawing more amperage. We're drawing more than 0.3 of an amp at 1 volt now, as opposed to 0.2 with the light bulb by itself. So in a parallel circuit, the more devices, the more amps are being pulled on the circuit, as opposed to series, where it's actually less. But see, then you're sacrificing the voltage and also creating a single point of failure in the circuit across all the devices. Let's shut off here. And that about wraps it up for series and parallel circuits.